Namaste and hello. This video captures how you can leverage our LyoTwin Process app to take the uncertainty out and expedite your lyophilization process development efforts. Lyophilization is an important and often an expensive step in the pharma and other industries. Typically, this involves drying to the required moisture content, a temperature-sensitive formulation in a liquid form to a free-flowing powder form without degrading. Since the step can run into several days, any uncertainties here can be very risky. Given the complexity of the process, some of the challenges faced by the end user, say in the pharma space, can include, for any given formulation, what drying cycle to use on a given lyophilizer to get the product of the right quality. How can we optimize the cycle time to meet the business needs? And how do we ensure that the results that we are observing at the lab scale hold true even at the manufacturing scale without any surprises? Traditional approaches without linking the underlying process, material, and equipment interactions can lead to the design of non-optimal lyo cycles, which can result in multiple trials and errors in the course of optimization. Also, this leads to increased risk during tech transfer. This is where LyoTwin can help you. Let's look at how. LyoTwin is built upon published technical understanding of how the finished product quality is impacted by the underlying interactions of the properties of the material being dried, the lyophilizer equipment, and the process conditions. Let's take a look at a few modules of LyoTwin. Each lyophilizer is different. A cycle that works for a product on one unit is not guaranteed to work on a different unit. So it's important to understand the equipment characteristics and design processes appropriately. LyoTwin has modules to help you with such needs. This example shows how you can input data from custom weight loss or freezing experiments to obtain heat transfer coefficients and their variation within the lyophilizer. It is also important to understand your product characteristics like the cake resistance, as they can vary with process conditions and impact the decision making on lyo cycle definitions. While literature data exists for some systems, in case you prefer to characterize your system, you can use the cake resistance module as shown here. Once you define the details of the custom experimental lyo runs and the process conditions used, the module back calculates the variations of the cake resistance and help you with your design of the lyo cycles. With the knowledge of the relevant material properties and the equipment characteristics, you should be ready to design an optimal lyo cycle. This is where the cycle optimizer module comes into picture. In this step, you can define the safety margins on equipment limitations, nucleation, and critical product temperatures based on your understanding of the system. The recommended optimal cycle, comprising of the freezing, primary, and secondary drying steps, keeps the product temperature below the critical value and the process window in an optimal location within the safe region of the design space. In addition to providing a recommendation for an optimal lyo cycle, the module also shows how the product temperature and drying front can be expected to evolve with time to help with any of your decision making. LyoTwin helps you understand your product and your equipment better. It expedites your lyophilization process journey by reducing unnecessary trials and mitigating risks during tech transfer. The LyoTwin app can be customized for your organization needs so that you can integrate it with your Industry 4.0 vision. Please contact us to discuss your process needs and to know more details about the LyoTwin Process app. Thank you for watching.